All right, for example 1, state the equation in slope point form of the line through the given point with the given slope. So the first thing I'm going to do is I'm going to state I have y minus whatever y1 is equal to m x minus whatever x1 is. I'm going to drop the numbers in where they go. So here's my x, here's my y, and there's my m. So it's going to be y minus 5 is equal to 3x minus 6. And the reason I put in these brackets for right now is to watch for double negatives, like with our slope equation. Y minus 5 is equal to 3 bracket x minus 6. And there's my equation. If I look at the second one, I'm going to say that I have y minus, in this case is going to be negative 1, is equal to negative 4 bracket x minus 1. When I get rid of the brackets, that y minus negative 1 is going to become y plus 1 is equal to negative 4 x minus 1. If you don't want to do the double brackets, just remember that for the coordinates in the equation, you're going to flip the sign. If it says that it's negative in the equation, it's going to become plus that. If it says that it's plus that in the equation, it's going, or in the coordinates, it's going to be minus that in the equation. So for this one, I can say that I have y, if it's negative 8, it's going to become plus 8, is equal to 1 over 2, x minus 9 is going to become plus 9. And there's my equation. In each case, the slope of a line and a point of the line are given. Determine the equation of the line in slope-intercept form. Well, if all I have is the slope and a point, I always need to start in slope point form. So I'm going to start by stating this would be y minus 2 is equal to 5 bracket x plus 5. Now I can convert that. All I need to do to convert that is I'm going to multiply the m value into the brackets, whatever the m happens to be, and then I'm going to move the constant on the y side over. So I'm going to say y minus 2 is equal to 5x plus 25, and then when I move that negative 2 over, y is equal to 5x plus 27. And there's my answer. Do the same thing for b. I'm going to start by stating that it's going to be y minus 4 is equal to negative 7 bracket x plus 3. I'm going to multiply my m into the brackets. Y minus 4 is equal to negative 7x minus 21. And then I'm going to move my constant over. Y is equal to negative 7x minus 17. And there's my equation. John and Nikki were solving the following quiz question. Determine the equation in general form of a line with a slope of negative 2 passing through the point of 3 and negative 5. John can only remember the slope y-intercept form, but Nikki remembered the slope point form. Complete their work, which is started below. So for John, all he did was he left the y is equal to mx plus b, where he knew the slope was negative 2, and then he substituted the point in for the x and y. So for him, what he's actually doing is he is stating that negative 5 is equal to negative 6b, plus b, or when he adds the 6 to both sides, 1 is equal to b. And if he knows what the b value is and he knows what the m value is, he said y is equal to negative 2x plus 1. Nikki knew the slope-intercept form, so she substituted in the m value, she substituted in the coordinates, and she's going to do the same thing that we did with our last examples. She said y plus 5 is equal to negative 2, and I'm going to multiply the negative 2 into both parts here, negative 2x plus 6, and then I'm going to subtract 5 from both sides. Y is equal to negative 2x plus 1, and they both got the exact same answer. For example 4, the line on the grid passes through at least 2 points with integer coordinates. Determine the equation in general form. Well, to determine it in general form, I first need to figure it out in a different form. Here, I can take a look, and here would be my y-intercept, but we can tell that it's not an exact integer, so I can't use that as my point. So I'm going to find any other points that I have for exact integers. I can see one point that exists here, and I'm going to call that point negative 6 and 0. And then when I'm looking for another point, I have another point that exists here. I have another point that exists here. I just need one other point. I can call this point negative 2 and negative 3. I can figure out what my slope was going to those points because I went down by 3 and I went right by 4, which means that my slope is negative 3 over 4. So I can use either of these coordinates that I have picked to solve this. It doesn't matter which one because it will always give me the same answer in general form or in slope-intercept form once I convert it. So in this case, let's take this point. There's my slope, there's my point, and I'm going to state that y minus negative 3, which would be y plus 3, is equal to negative 3 over 4, bracket, x minus negative 2, or x plus 2. Then I would do the same process I would to convert it into my slope-intercept form to begin with. I'm going to multiply everything out, and I'm going to say y plus 3 is equal to negative 3 over 4x minus 6 over 4. And now I don't want fractions. So I can move everything to the left-hand side first, or I can just get rid of the fractions. In order to get rid of the fractions, I need to multiply by the common denominator, which is 4. Multiply all this by 4, multiply all this by 4. And what I'm going to wind up with is 4y plus 12 is equal to negative 3x minus 6. At this point, because I can see that x is negative, I'm going to wind up moving everything to the left-hand side. So I'm going to add 3x to both sides. This 4y, and the 12 plus 6 is going to give me plus 18 is equal to 0. There's my general form. In each case, state the slope of the line and write the coordinates of a point on the line. Well, for the first one, I have a slope of 1 over 7, and the coordinate points that I have are going to be, if x minus 4, then the x value is going to be positive 4. If it's x plus 11, or y plus 11, the y value is going to be negative 11. In the second case, I have a slope of negative 5 over 3, and the coordinates are x minus 7, so it's going to be positive 7 for x, and y minus 9 is going to be positive 9 for y. Down here, I'm going to have y is equal to negative 3x minus 6. Well, the slope is still going to be negative 3, and the coordinates, if it's x minus 6, it's going to be positive 6, and if y does not have another number there, that would be the same as minus 0. So I have the point of 6 and 0. And for the last one, I'm going to wind up stating that here I have a slope of negative 3. And because this is in slope-intercept form, I don't have these brackets like I did in the last one, then that means that this is actually my y-intercept, or b value. So I'm going to state that my coordinate is at 0 and 6, where my y-intercept would be.